In this clip, we'll take a look at how to handle what's probably the shortest sounding math problem you're ever likely to read. And that's one where you've been given a right triangle that looks something like that, and then the question just says, solve it. Solve triangle ABC. That's it. But what does that really mean to solve a triangle? Well, what they're asking for is just fill in the gaps. Anything you don't see in the diagram, you have to use your math skills to solve. So for instance, angle A doesn't have any number right here, so I'll have to find the answer to that. Also, AB, this line segment right here, or which we'll call C because it's the opposite line to this angle, it doesn't have any value either. And same for line A. It matches this angle, but there's no line length for it either. So three things to solve for: this angle and then two line lengths. Let's go to step one. All three angles must add up to 180 degrees. So angle A, C, and B must be 180 degrees. So that's a little trick we can use all the time when we're solving triangles that'll help us speed up our work. So I'm just going to say angle A is equal to 180, and from that I'll subtract what these two angles add up to. One is 90, one is 65. 90 plus 65 is 155. And from there, it's just a subtraction problem. 180 minus 155, that's 25. And since we're solving for an angle, I'll say degrees. There, we found one piece of the puzzle already. So I'm going to carefully label angle A as 25 degrees. And now I've solved for all three angles in the triangle. I just need to solve for the lengths of the remaining two lines, and that's step two. At this point, it doesn't really matter which line segment we choose. We could choose what we'll call a lowercase c, since it matches this angle, or this line here, which we'll call lowercase a, since it matches this angle. I'm going to go ahead and choose C, and we'll solve for the length of that first. So what I'll do is I'll position myself right here at angle B, which is 65 degrees. And now it's time to break out some trigonometry skills. I need to think about SOHCAHTOA, and those are three tools I have at my disposal. And I have to figure out which one works best for me in this situation. Well, SO in SOHCAHTOA is SOH, or sine is opposite over hypotenuse. So if I'm right here, opposite over hypotenuse, that's not a bad choice because I have the 65 degrees and I also have a length given here for the opposite, and then I could just solve for the H in SO, which is the lowercase c. So I'm going to do that. Let me show you how I set this up. We'll set up our ratio first. I'll say sine, and then the angle is given as 65, and it's equal to opposite over hypotenuse. So opposite is 15.5, and the hypotenuse is what we don't know, and that's the lowercase c. From there, it's a matter of isolating c. And to do that, we need to break out some cross multiplication. So I'm going to add a 1 under my sine 65. And the reason I do that is that it's just a nice visual tool to help me remember how to do my cross multiplication. The first step is c times sine 65, and that will be equal to the cross, which is 1 times 15.5. So let's do that now. C times sine 65 is equal to the other red arrow there, which is 1 times 15.5, so that's just 15.5. Okay, and now I need to isolate for c. It's multiplying something, so the opposite of multiplication is division. So I'm going to divide both sides by sine 65, and that will leave c all by itself. Sine 65 is equal to 15.5 divided by sine 65. And the reason I do that is so that now there's a sine 65 on top and one on the bottom, and in effect they have just canceled each other out. So my next line will be c equals, and whatever this is, 15.5 divided by sine 65. For this, we need to break out our scientific calculator. So let's get that up on the screen and I'll show you that step. 15.5 is divided by sine, which is this button right here, sine 65. And I get an answer of 17.102. We'll just round that to say 17.1 because one of the given side lengths was rounded to 1 decimal place. So 17.1. And let's not forget our units. Since we're talking about centimeters, we should include that. And now I've just found C, so let's add that to the puzzle as well, 17.1 centimeters. Okay, we're making some progress here. There's only one line left, and that's line A, and that'll be step 3. If I position myself at angle A, which is 25 degrees, I can do sine again. I can do sine of 25 is opposite over hypotenuse, A over 17.1. That'll work nicely for us. Let's set that ratio up. Sine 25 is equal to O over H, opposite over hypotenuse. Remember SOHCAHTOA. The O is the A, and the H we just found, 17.1. And now it's just like step 2. We need to cross multiply. So I'll put that 1 underneath, and we'll have 17.1 times sine 25 is equal to 1 times A. 17.1 times sine 25 is just equal to 1 times A. I'll just say A. And finally, I'll just say A equals, just flip that around. This operation I can do on my calculator again. So let's bring that in. 17.1 times sine 25, 7.2 we'll say. 7.2 centimeters. And if I add that to the diagram, it's all complete. I've finished my puzzle. I have solved triangle ABC. Okay, now it's your turn to practice solving a triangle. So grab your pencil, paper, and scientific calculator because I'd like you to try and solve this triangle. And I'll post the solution when you're ready. And here's your solution. Angle A is 35 degrees, side C is 13 centimeters, and sine A is 7.5 centimeters.